Hello everyone, and welcome to Biopedia. This week we're going to discuss assortative mating, the non-random mating within a population that owes its existence to natural selection. Now, when making theories and models, biologists often make assumptions. However much they might wish this weren't the case, sometimes simplifications and assumptions don't stack up to the truth. Such is the case with the idea of random mating. Assortative mating describes the phenomenon where choice of mates seems to be correlated to the genetics of the partner for a particular trait. The opposite of this would be disassortative mating, whereby individuals with a particular trait or phenotype seem to mate with each other less than you would expect if it were random. Some studies have found that, in some populations, there is a certain degree of relationship between partners that seems to promote fertility. In an Icelandic study, it was found that couples who were third or fourth cousins, which means that they either shared a pair of great-great-grandparents or third-great-grandparents respectively, had optimal fertility, as reported in a 2020 paper on the subject of assortative mating. I'm not sure if this effect would be limited to an environment such as Iceland, where the population size is limited, as this isn't really mentioned in the paper I accessed. This paper also mentioned that, on the whole within the population, there is a whole genome assortativity somewhere between the level of fourth and fifth cousins. Using data from 1,683 couples from two sources, it was found that the kinship coefficient, used in this instance as a measure of how similar spouse genomes are and how closely the couple is related, was significantly higher than if the mating process had been truly random. The paper states that some degree of similarity might well increase levels of fitness, presumably within the context that, if there is a beneficial allele within what I'm going to call a tribe, choosing, in air quotes, a distant cousin as your partner would mean that that gene is more likely to be inherited by your children. If it is recessive, for example, a distant cousin has a greater probability of also having inherited that recessive allele, which means it's more likely to be passed on. It's amplified, if you will, in that sense. I don't know for certain if this is why, as the review paper doesn't mention this process explicitly, but if I find out anything more about this, I will update you, either in the podcast feed or on the website. Assortative mating has also had a role in accelerating the pace of evolution for some traits within humans over the past 30,000 years. This is because it acts to increase the gene frequency within a population of a gene. If organisms with a beneficial allele mate, through their descendants they will increase its frequency. In this way, alleles which have in recent evolutionary history been associated with assortative selection have been shown to have stronger signals of positive selection. Now, we can go further with this conclusion. Choosing a mate, and indeed monogamy, are the result of cultural choices and cultural selection. This demonstrates that cultural evolution can, in fact, play a role in genetic evolution. We could still explore this in more detail, but as this is only meant to be a quick primer, I'm going to leave it here for now. In the meantime, you can get in touch with the show at biopediapodcast@gmail.com for any questions, comments, or topic suggestions. Thank you for listening, and until next time, have a great week, everyone.